Welcome to the series of learning lessons on mathematical inductions. As we've done previously, we have learned what is mathematical inductions, the various definition of mathematical induction. This lesson tries to show you the various steps that you will need to carry out when you are faced with a mathematical induction problem. Let's look at the stages of mathematical induction. When we are having a problem on mathematical inductions, there are basically two steps involved. We have the initial step. That is where you prove that the proposition given, the proposition is always the problem given in the question. So the proposition given is true for n is equal to 1. Or if the assertion is that the proposition is true for n is greater or equal to a, then prove it for n is equal to a. What it implies that certain proposition does not start from n is equal to 1. It probably may start from when n is equal to maybe 5 and above or 3 and above. So when it happens like that, you prove it at the base level. So when the proposition is stated that it is true or the statement is valid for n is equal to, let's say, 10 and above, then the base will be 10. So that's the base case. You prove the base case. So first and foremost, the initial step is to prove the proposition at the base level when n is equal to 1. Most propositions always start with 1. But in a situation where it doesn't start with 1 and it starts from a certain number, you start from that base. Then the second step is what we call the inductive steps. The inductive step, you prove that if the proposition is true for n is equal to k, then it must also be true for n is equal to k plus 1. This step is very difficult. It is a very difficult part. It may help for you to understand. I would like to break it into several stages. So there are two steps. The first step is to prove that the proposition is true at the base level. At the base level, most of the time, n is equal to 1. Or depending on how the proposition has been defined. If it's defined that n is equal to a certain number, let's say a, or an above, then its base level will be a. Then you move to the next level, that's the inductive level. At that stage, you prove that if it is true for n is equal to k, then it must also be true for n is equal to k plus 1. Let's look at the inductive steps. What are the stages in the inductive steps? There are 3 stages in the inductive steps. Let's look at them. Stage 1, you write down what the proposition asserts for the case n is equal to k. This is what you are going to assume. At this level, it is called the inductive hypothesis. So when you write the assertion for when n is equal to k, we don't argue about that. We say it is true. We accept it. It's like a hypothesis. In the second stage, that you are going to use that your assertion or your earlier presumption or earlier hypothesis in stage 1 to prove that the assertion given is either true or false. So in stage 2, you write down what the proposition asserts for the case n is equal to k plus 1. And this is what you have to prove. We have to always keep in mind as you go on. Then after you have written down what the proposition asserts for the case n is equal to k plus 1, which is not always easy. Stage 1 and stage 2 for the inductive step is always easy. Writing down the proposition for the k as the proposition asserts for the value of n is equal to k, and the second stage, writing down what the proposition asserts for the case of n is equal to k plus 1 is always easier. Then stage 3 is always the problem. Stage 3, you prove the statement in stage 2. using the assumption in stage 1. That's using the proposition, the inductive hypothesis. So you are going to prove your stage 2, the case where n is equal to k plus 1, using what? Your inductive hypothesis. Remember, we can't give you any recipe for how to do this. It varies from problem to problem, depending on the mathematical content. You have to use your ingenuity, your common sense, and knowledge of mathematics here. The question is to ask, how can I get from stage 1 to what? Stage 2. So you are going to use the hypothesis, the inductive hypothesis, to prove the case when n is equal to k plus 1. And there is no defined step-by-step procedure. There is no a recipe on how it should be done. You are going to use what? Your ingenuity, your common sense, your mathematical knowledge, your skills to arrive at stage 2. When that is done, then you can draw your conclusion. So once the initial and the inductive steps have been carried out, then we can now conclude immediately that the proposition is true for all n greater or equal to 1, or for all n greater or equal to a, if the particular problem or proposition does not start from 1. So this is just an introduction. In the videos that follows, we are going to use examples to illustrate how these steps we employ. So keep calm as we roll up the examples. Thank you.